In the last couple of sections, we put our repository class together. Now the code we have inside of here is looking pretty good, but there's one little issue with it that I want to mention just really quickly. So at present, we've got two ways of kind of storing and retrieving news articles inside of our application. We've got the database provider and the API provider. And then the code inside of, say, fetch item right here is very, very much customized to working just with those two providers. So although our repository works absolutely fine as it stands right now, I want to throw a little bit of a curveball in here. Let's say that maybe at some point in the future, we decide to introduce some new provider to our application, something called, like, let's say, news cache provider. And maybe this represents just some other way of storing news articles or retrieving them at some point in the future. So maybe it would be similar to the database provider, I don't know, just some other way of storing news. So if we introduce this new provider into our repository class right here, I think they would be very clear that we would have to do a very significant refactor of the fetch item method right here. We would now have to look at that cache provider and decide, okay, are we going to look at that thing before we go to the database or after? And once we get an item from, say, the API, are we going to pass that back to the cache provider as well, or do we not worry about updating the cache provider? So although it looks like our repository class right now works and is okay as it stands, I think that it might not really stand the test of time. I think that it might not be quite as easy to upgrade or expand at some point in the future as our application starts to get more complicated. So to solve that, we're going to kind of rebuild our repository class. Now that might sound like it's a really boring thing to do. I know we just put the repository together and you're probably thinking, Stephen, I don't want to rebuild this right away. But I'm gonna tell you what, I'm really, really excited about doing this refactor because this is one of those very few places where I get to really teach you a lot about some of the core design principles of Dart applications. So even though we're gonna be rewriting some code, I guarantee you it will be worth it. Let's take a quick pause right here. When we come back to the next section, we're going to start talking about a little new feature that we haven't spoken about before in the Dart language. So we're going to learn a little new thing inside of Dart first, and then we're going to use that new feature to come back over to the class repository right here and do a refactor to it to make it far more reusable for the future. So quick pause, and I'll see you in just a minute. In the last section, I made the claim that our class repository right here might be a little bit challenging to expand or refactor in the future. And so we're going to do a refactor right now to make it easier to add in additional providers. Now the process of doing this refactor is going to be just a little bit complicated. So I want to look at a diagram that's going to lay out exactly how we're going to do this refactor. Okay, so very plain and simple steps here. The repository class has issues. I want to be very direct. I'm going to tell you right now, we're going to solve those issues by using a new feature in Dart that we've not yet discussed called abstract classes. Abstract classes are a feature in the Dart language itself. It's not something that's necessarily unique to just Flutter. Now here's the thing about abstract classes. Understanding them can be a little bit challenging. Or maybe a better way to put it would be to say it can be challenging to understand why we want to use abstract classes. So rather than just diving into this refactor and rewriting all the code in our repository class, I want to first tell you a quick story or a quick analogy to help you understand first what an abstract class is, and secondly, why we care about them at all and why we would use them at all. So once we understand that, then we're going to go back and refactor our repository. So with that in mind, let's now continue by doing a very quick little story. So quick and little analogy here that's going to give you a better idea of what a abstract class is and why we care about it. So here's the story. I want you to imagine for a second that instead of building an application to display news stories, maybe we are instead writing some Dart code to control an energy grid, like an electricity grid, the type that supplies electricity to your home. So here's your house right here. Here's the energy grid. A power plant gets connected to this grid. It exports electricity to that grid, which then flows into your house and supplies your light bulbs, or it powers your computer, powers your refrigerator, or whatever else you have. Now, if you don't know a lot about energy grids, there's actually a very interesting way in which they work. Throughout the day, the energy grid gets different levels of what we call demand. So in other words, throughout the day, maybe at 2 a.m., there are very few people making use of electricity in their homes because everyone is asleep at 2 a.m. So at 2 a.m., we might be able to meet the entire demands of all electricity for everyone inside of a city or some type of region with just one power plant like so. So at 2 a.m., all power demands can be met by exactly one power plant, which we'll refer to right here as nuclear plant A. But as time goes on throughout the day, and it starts to get towards the afternoon, like let's say 5 p.m., more people start to go home from work, they start to turn on their TV, maybe it starts to get hot outside at 5 p.m., and people start to turn on their air conditioning, and so at 5 p.m., there's greater demand for electricity on the energy grid. And so at 5 p.m., we might want to turn on a second power plant and have that also start to supply power to the energy grid to meet that rising demand. And then as it starts to cool down and it starts to go back to 2 a.m. again, maybe we don't need power plant B right here anymore, and so we decide to remove it from the grid. And we turn that power plant off and we say, hey, thanks power plant B, but we don't need you until tomorrow. So that might seem like it's not very related to our repository stuff right now, but let's just write out a little bit of code. I want to write out a little bit of Dart code to kind of model this situation right here. So I'm going to flip on over to Dartpad. Remember, we can get here at dartpad.dartlang.org, and we're going to write out just a little bit of code to model an energy grid and a nuclear power plant and how they kind of interact with each other. So back over inside of Dartpad, I'm going to start off by making two classes. One to represent the power grid, and then one to represent a nuclear power plant, like so. Now the power grid itself probably is going to need to have some functionality tied to it that knows exactly what power plants are currently connected to it, like the fact that power plant A is currently connected to it. So we're probably going to have some storage mechanism to say, okay, energy grid is currently connected to power plant A, and we'll probably need some type of method to make sure that the two can kind of get connected together. So inside of power grid right here, I'm going to make a new instance variable that's going to be a list that will store instances of nuclear power plants. I will call this instance variable connected plants, and that's going to be a list like so. And then I'm going to add a method to the class that can be called with an instance of a nuclear plant. Whenever we call that with a nuclear power plant, it'll be added to our connected plants list right here. And so I'll add on something like add plant. We'll call that with a variable of type nuclear plant, and we'll refer to that variable as plant. Then we'll go connected plants.add plant, like so. Okay, so everything we have right here, not too bad, definitely models relationship. Now I want to add in just one additional little requirement here. Let's imagine, I don't really know how nuclear power plants work, I'll be honest with you, but let's imagine that when a power plant is not connected to the grid, it's in some type of like off state. And so anytime that we connect a power plant, we have to kind of toggle the nuclear plant to being on. We have to like turn it on essentially. Now we could represent that with a Boolean on the nuclear power plant, but let's make it a little bit more straightforward. Let's just add a method to the nuclear plant called turn on. And whenever we call that thing, we'll just print out something like, I'm a nuclear plant turning on. And then anytime we call add plant right here, we'll make sure that we first turn the plant on by calling turn on. So plant.turn on. And then once it's turned on, we'll then add it to our list of connected plants. All right, so everything that we have at this point in time absolutely looks pretty darn reasonable. So let's take a quick pause right here. We'll come back to the next section, and I'm going to throw a little bit of a wrench into our power grid. And once I add this wrench in, you'll start to see why we need this thing called abstract classes. So quick break, and I'll see you in just a minute. In the last section, we put together some code to model a power grid and a nuclear plant. Now I want to, last thing here, add in a main function and write out a little bit of code to create an instance of a power grid and then create a nuclear plant and attempt to add it to that grid. So at the top, I'm going to add in void main. I'm going to make a power grid. I'm going to make a nuclear plant that I'll call nuclear. And then I'm going to take the grid and I'm going to add nuclear to it. So I'll say grid.addPlant and I'll pass in nuclear like so. And so at this point, everything looks like it's working just fine. If I click on run right here, I can wait for the refresh on the top right hand side and I'll see the print statement of I'm a nuclear plant turning on. So no issue whatsoever. Now one thing I want to point out here is that it's very clear that we have customized our power grid to work exclusively with nuclear power plants. 100%. We are saying that the power grid is always going to have references to nuclear plants, and we've also customized the add plant function to specifically watch for nuclear plants to be passed in. So let's now throw a wrench in here. Let's add in something that's going to throw all this code out of whack and require us to refactor it entirely. So back over on this diagram, let's imagine for a second that it turns out people don't really like living next to a big nuclear power plant. And so maybe the residents of our city are saying, hey, you know what? We don't want to use nuclear power anymore. We understand that maybe we have to use it sometimes, but we want to use solar instead. So maybe we decide to make another type of power plant that should be able to connect to the exact same energy grid. So we're going to build a solar power plant, and we would expect to be able to connect it to our energy grid in exactly the same way that we currently do our nuclear power plants. So let's now try going back over to Dartpad, and we're going to add in a new class to represent the solar plant, and then we'll try to get that to work with the energy grid. So back over here, I'm going to go down to the bottom. I'll add on class solar plant. I'm going to add a turn on method to it. And whenever we call that, I'll print out I'm a solar plant turning on. So now up inside of our main function, I'm going to create a new a new solar plant. I'll call it solar. And now right after adding in the nuclear plant, I'm going to attempt to add in the solar one as well. So grid.addPlant solar. And as you would expect, we're going to see a big nasty error message that says, hey, you're trying to pass in a solar plant here to a method that very clearly is expecting to be called with a nuclear plant. But hey, here's the thing. Take a look at this. We've now put together a nuclear plant and a solar plant. And it's very clear that, at least inside of our story, you and I expect the nuclear plant and the solar plant to behave in exactly the same way. They are both supposed to be supplying energy to our energy grid. And they both have methods called something like turn on. But at this point in time, we have built our power grid in such a way that it is 100% customized to only work properly with nuclear plants. So that's the big issue, and that's kind of the issue that we're running up into inside of our repository. We have put everything together inside of our repository, assuming that we have exactly one database provider and one API provider, and the two of them are always going to work together in some very specific fashion. And so as soon as we start to add in another provider, or as soon as we start to add in another power plant, it starts to throw all of our code out of whack. So hopefully you're starting to see kind of parallels between these two examples. So let's take one more break. We're going to come back to the next section and start talking about what abstract classes are and how they're going to solve this situation. In the last section, we tried to add in the idea of a solar plant to our example of a power grid. However, we ran into an issue immediately because we set up the power grid always expecting to be working with a nuclear plant at all times. So let's take a look at a diagram or two. They're going to give you a better idea of how we're going to solve this. So the first two questions I want to ask you, I want you to think about the energy grid, and I want you to think about what that grid class looks for in power plants that we're trying to add to it. If you go back over to our example, The only kind of requirement right now of our power grid is that if you try to add in a plant, it has to have this turn on method. And so the next question I want to ask you, what's the common thing between the nuclear plant and the solar plant? I think it's clear that both those classes have a method assigned to them called turn on. And so if we just had the ability to tell Power Grid, hey, you know what, Power Grid, if you get called with absolutely any argument right here with some type that has a turn on method assigned to it, then just assume everything is good to go. Assume it's fine. Assume that it is a A-OK power plant and it can be successfully added onto our list of connected plants right here. And so I think we should use the existence of the turn on method on any given class to say, you know what, if you have that turn on method, you're good to go, you qualify as a nuclear power plant. So to kind of express that in code, you and I are going to write out something called an abstract class. An abstract class defines a new type inside of our application. We can use abstract classes in place of these more specific types that we might use in some locations of our code. So thinking back to the power grid right here, it'd be really nice if we could be less specific with the type that we are expecting to see inside a power grid. And it would be really nice if we could just say, hey, you know what, you can work with a power grid with anything that has the method turn on. Okay, so let's start to write out a little bit of code here and actually get a better sense of how this works. So underneath my power grid class, I'm going to write out abstract class power plant, like so. And then inside of this class definition, I'm going to write out all of the methods and instance variables that I would expect something that is a power plant to have. So as we just said, we would really expect any power plant in existence to have a method tied to it called turn on. So I'm going to write out turn on. I'm going to put my parentheses, and then I am not going to define a function body. I'm just going to put a semicolon like so. So that's all we need to define an abstract class. We've now defined a new type inside of our application that essentially says, hey, you know what? If you have a turn on method, you qualify as a power plant. Now it's not quite that easy. We got to do a quick thing to both the solar plant and the nuclear plant. On both these, after writing out the class definition, I'm going to add on implements power plant and implements power plant, like so. So the implements keyword right here tells the Dart compiler that you and I are going to try to put together implementations or classes that are going to satisfy the interface defined by the abstract class of power plant. And so this says to Dart, hey, you know what? We're trying to make a power plant right here. Please validate the class that we're putting together and make sure that we meet all the requirements that are needed to be qualified as a power plant. And so Dart looks at nuclear plant right here. It looks at power plant right here. It says, okay, to qualify as a power plant, you have to have a turn on method. And so then it looks down at our class. It says, oh, you have a turn on method. Congratulations, you qualify as a power plant. And then it repeats the same process with solar plant down here as well. The Dart compiler looks at power plant. It says, okay, power plants are supposed to have a turn on method. Here is the solar plant. You have a turn on method. Congratulations, you qualify as a power plant as well. So now that our nuclear plant and solar plant qualify as power plants, we can refactor the power grid up here. We're going to say that rather than storing a list of nuclear plants, we're going to store a list of classes that qualify as power plants. And so we now have access to a new type inside of our application of power plant. So rather than putting nuclear plant right here, I'm going to put power plant instead. And then I'm going to replace the argument type annotation on add plant with power plant as well. And then as soon as I do, you'll notice that our error message goes away. So now I can try to run my code, and I would expect to see two print statements up here. So we now see I'm a nuclear plant and a solar plant. So let's talk about what just happened here. We defined a new abstract class inside of our application. This introduces a new type of power plant. Inside of the abstract class definition, we can write out all the different instance variables and all the different methods that we would expect a class to have if it wants to qualify as a power plant. We then put together our implementation for all of our normal classes, and then write out implements power plant. And then again, that tells the Dart compiler that we want it to look at the power plant abstract class, look at all the instance variables and methods tied to it, and then make sure that our class qualifies as a power plant as well. So then, anytime that we want to make use of either one of those power plants, either the solar plant or the nuclear plant, rather than being very specific and saying, oh yeah, you have to be a nuclear plant or a solar plant, we can just say, you know what, as long as you pass anything that qualifies as a power plant to the add plant method, you're good to go. You have a legitimate working power plant. Okay, so that's it. That is abstract classes in a nutshell. It's all about writing more reusable code. And so I think that you might be getting to get a little bit of a sense of how we would refactor our repository. We might want to make a new abstract class that says, okay, if you want to be a provider, you must implement this certain set of methods. And if you look at both our DB provider and the API provider, you might have noticed that on both of them, we added on a fetch item method that works almost identically. And so we might be able to make a new abstract class that kind of describes how a provider should behave. It should have a fetch item method that can take an ID and eventually return an item model. So we've kind of already done some of the legwork of setting up our providers appropriately, but we'll get to all that stuff in a moment. First, I want to take a quick break. I want to come back to the next section, and I want to tell you just a little bit more about the syntax around abstract classes, just to give you a better sense of how we can be a little bit more specific in how they work and how you can qualify as being an abstract class. So quick break, and I'll see you in just a minute. In the last section, we finally started to implement our first abstract class. Now, before we move on and start to do our refactor of the repository, I want to point out a couple of interesting things about the abstract class right here and just tell you a little bit more about the syntax around it. So first off, inside of an abstract class, we can define instance variables and methods. Right here is an example of defining a method. You'll notice that we did not define a body with this method. So we are essentially just saying, hey, you know what? To qualify as a power plant, you have to define a turn on method. We're not making any claim about what that method does whatsoever. There's no claim saying, oh, if you call turn on, you have to print something. That's not happening. All we're saying is that you have to define a method called turn on. Now, in addition to just saying that you have to define this method, we can also make assertions about the types of data that should be returned and the types and number of arguments that it should receive. So for example, maybe we say that anytime the add plant method is called, rather than just calling the turn on method right here, maybe the power grid wants to call turn in, turn on, and also specify like how long the power plant should stay on for. And maybe we'll just specify that as a string of like 5 hours. So now we would have to do a refactor to our abstract class right here and say that if you want to qualify as a power plant, you have to define a turn on method that accepts a single argument of a string. And so to specify that, we would add in an argument of string duration like so. Now, the name that we use for this argument right here is entirely unimportant. We can give this any name we want. So it could be duration, time to stay on, when to turn off, whatever, I don't care. We just have to put some identifier inside there. More important is the type that we associate with that argument. So we have now changed our abstract class, and it now says, hey, if you want to qualify as a power plant, you have to define a turn on method that accepts an argument of a string. And so you'll now notice that inside of our two classes down here, we now see this error message that says invalid override. Our classes are trying to satisfy the power plant abstract class, but they are defining methods of turn on that do not accept any argument whatsoever. And so we would now have to refactor both these classes and say that they both accept a string, and we can call that argument anything we want. It does not have to be duration. It could be time to stay on. And then down here, we could accept that argument, and we could instead call it like how long on or something like that. So the only thing that is important here is making sure that we have the same number and type of arguments. The actual names that we're putting in here, not important. We can put in anything we want, but in general, as you might imagine, you'd want to use names that kind of communicate the purpose of that argument. Now, in addition to specifying arguments inside of our abstract class, we can also require certain return types. So for example, maybe we say that whenever the power plant gets turned on, we want it to return a Boolean that we'll call like confirmation. And so maybe this Boolean right here is supposed to say, hey, like I confirm, yes, we can be on for 5 hours total. So now we would want to update our abstract class right here and make sure that it's really clear that if you call turn on, we want you to return a value of type Boolean. So in front of turn on, I'm going to add on type bool, like so. Now you'll notice that I'm not seeing an error message down here. That's an oddity of Dartpad. In fact, we are required to make sure that our turn on and turn on methods right here do return a Boolean. So to now satisfy the abstract class requirement, I need to make sure that turn on and turn on both return a Boolean. So I will annotate the return types as bool. And then on both of them, I'm going to return like, maybe true, and maybe the solar plant's not so good, and that will return false instead. Okay, so one last demonstration here. One last thing. I've said several times that a power plant or an abstract class, can define both requirements for methods. They can also define requirements for instance variables as well. So we could also say that a power plant must have some cost of electricity. And maybe that should be an integer. So maybe to qualify as a power plant, you must have an integer instance variable. Now, unlike the name of the arguments down here, the name of the instance variables inside of your class that is trying to implement this abstract class has to be consistent. So now, if you hover over nuclear plant right here, or if you look at the error message on the bottom right-hand side, it says missing concrete implementation of power plant cost of energy. So we're now saying if you want to qualify as a power plant, you have to have an integer instance variable called cost of energy. And so now inside of our class, we would have to define an int cost of energy. And then down here, we have to define an int of cost of energy, like so. Okay, so that's pretty much it for abstract classes. Again, the entire idea here is that we sometimes want to write code that can work with a variety of different types. And maybe our class of PowerGrid right here, it does not care at all about the internal implementation of how a plant is put together or what it's really doing. All the PowerGrid cares about is that the power plant it's working with is going to have a method called turn on that accepts a string and returns a Boolean. And that's the only thing that the PowerGrid cares about. And so to satisfy that, we can create a abstract class, write those requirements inside of there, and then anytime we want to create a new class that can work with the PowerGrid's add plant method, we can create that class, we can implement the abstract class, and then we can attempt to satisfy the abstract class by essentially implementing the instance variables and the methods that we listed out inside there. So with all this stuff in mind, let's now take a quick break. We're going to go back over to our class repository, and we're going to do a huge refactor of this thing right here to make use of abstract classes to be a lot more flexible than it currently is. So quick break, and I'll see you in just a minute. In the last section, we finally got a really good idea of what an abstract class is and why we use them. Now, there's one last quick thing I want to mention about abstract classes, just to make sure this is really crystal clear. Down here inside of Nuclear Plant, we are attempting to implement the Power Plant abstract class. And right now, Power Plant has just the integer and the turn on method. So just to make sure it's really clear, I want you to understand if we want to, we can add additional methods or instance variables onto the Nuclear Plant class right here. So if we want the Nuclear Plant to also have a meltdown method assigned to it that blows up like so, no problem whatsoever. So when we start to implement an abstract class, all that's saying is what we have to have. It doesn't say that we cannot have anything else. So we can freely add on as many additional instance variables or methods to nuclear power plant or solar plant for that matter as we want. Okay, so now that we know how this stuff works, we need to start thinking about our repository and how we're going to do a refactor over here using abstract classes. So hopefully at this point, it might be kind of clear that we're probably going to want to put together some like provider abstract class that kind of models the relationship between a repository and a given provider. Let's start looking at a couple diagrams and try to understand the relationship or the kind of contract as it stands right now between the repository and these two providers. Okay, so back over here. Okay, so down at the very bottom is our DB provider and the API provider. At present, the API provider works with the repository through the fetch item method and the fetch top IDs method. And that's basically the only two methods that the API provider has at all. That's all it really does. It's got the client as well, but remember, we only put the client on there mostly for testing purposes. And then the DB provider has the add item method, which is used to store items. It has the ability to fetch an individual item. And then the DB provider does not actually have a fetch top IDs method, but remember we had said 100% we absolutely could implement this if we wanted to. We just didn't quite have enough time in the course to do it. So we're just going to imagine, for the purposes of all this abstract class stuff, that the DB provider does have a fetch top IDs method. It does not in reality, or at least yet it does not, but we're just going to imagine that it does. Because in reality, if we were building a serious application here, we absolutely would back up those top IDs to the database as well. Okay, so that kind of models the relationship between both these. Now, looking at the common methods between the two providers right here, it's very clear that both providers have the fetch item method, and then they both have fetch top IDs. Again, I know the database provider doesn't really, but again, we're just going to pretend that we went through that extra like hour to actually implement top IDs. So it's very clear that we could definitely implement an abstract class that says, yep, if you want to serve as a provider to the repository, you must have a fetch top IDs function and a fetch item function. But the thing that's kind of the odd one out here is this add item method. Honestly, I would really like to have this add item method represented inside of an abstract class because it's an extremely important part of the contract between the DB provider and the repository. However, if we add the add item method to our abstract class, then the API provider would not qualify as whatever we're going to call that abstract class because the API provider does not have add item. And it's very unlikely that it ever could, which is not the case with fetch top IDs. Fetch top IDs absolutely could belong on the database provider. So how are we going to solve this? We clearly cannot really make one abstract class here. We cannot have an abstract class that only gets like partially implemented by some given class. The API provider right here either has to add or implement add item, or it does not qualify as the abstract class. So as a possible solution, I'm going to suggest that maybe we kind of change our thinking about how the repository really works with these two providers. So let's look at another diagram. Okay, so I'm going to propose that we create two separate abstract classes. We'll call one abstract class a source, and then another abstract class we'll call a cache. So a class or a provider that qualifies as a source must implement the fetch item and the fetch top IDs functions. And so our database provider and the API provider absolutely would qualify as being sources because they both implement those methods. And then the cache abstract class over here describes any provider that can store items for use at some later date. And so in our application, the only class that qualifies as a cache by implementing the add item method would be the database provider. So that's how we're going to implement the interface or the contract with our repository. We'll have a set of classes that are sources, and then we'll have a set of classes that are caches and store data. Now, one other quick thing I want to mention here, you'll notice I listed the database provider under both these abstract classes. We absolutely can have a single class that implements multiple abstract classes. So if we wanted to, back over on Dartpad really quick, if I wanted to, I could add on another abstract class called something like, I don't know, a building, because power plants are sometimes buildings, I guess. And then maybe a building has a, I don't know, a height that's an integer. And so if we have a solar power plant that is built on the roof of a building, well, then maybe we would want that to qualify as a building. So the solar plant could implement both power plant and it could also implement a building like so. And now we'll see that power plant does not implement the height instance variable. And so I could fix that by defining height on it like so. So no problem in having a single class implement multiple abstract classes. Okay, so that's it. That's the refactor we're going to do. I know that it took quite a long time to get to this point, but honestly, I was really excited about these last couple lectures because I feel like this is those very rare opportunities I sometimes get to really communicate like these design patterns of ways that we can approach these problems rather than just saying like, oh yeah, let's just write out like very direct code as we did inside of our repository to kind of just satisfy the conditions that we have exactly right now inside this course for this application. Anyways, let's take a quick break. We're going to come back to the next section and we're going to start putting together our abstract classes for sources and caches. So quick break and I'll see you in just a minute. In the last section, we laid out the plan for defining abstract classes that are going to define the interface for working with the repository. So we're now going to flip back over to our code editor and start to implement both these abstract classes. Okay. So I'm going to define these abstract classes directly into the repository.dart file. I know that we had previously said that we only defined one class per file, but in this case, the abstract classes of source and cache are made specifically to work with the repository. And so it kind of makes sense to kind of co-locate it with the repository because they're all really intended to do the exact same thing. So down at the bottom of the file, I'm going to define an abstract class called source and an abstract class called cache. Now the source one is not going to be too bad. We can just go back over to, say, our API provider. And remember, we want anything that qualifies as a source to have fetch top IDs and fetch item. And they have to accept no arguments for fetch top IDs. And fetch item must accept an integer, a single argument of an integer. Fetch IDs has to have a return value of future list int, and fetch item has to have a return value of future item model. So back inside of my abstract class of source, I'm going to put those requirements for qualifying as a source into this abstract class. So I'll first do fetch top IDs. This thing is going to have no arguments required, so I'll leave that blank, but it must have a return value of future list int, like so. So we're now saying that to qualify as a source, you have to define fetch top IDs, must accept no arguments, and it must have this return value. Now we'll do the same thing for fetch item. For fetch item, you must pass in an integer, and then again we can put in any name for the variable right here that we want. I'm going to call it ID, because that kind of communicates what the purpose of this argument is. And then the return value will be future item model, like so. Okay, so we'll now flip back over to our API provider. We're going to import this abstract class, and then we're going to wire it up to the API provider directly. So here's my news API provider. At the top, I'm going to import repository.dart. And now I'm going to take what we just imported. We just imported the source abstract class. I'm going to say that I want to make sure that my news API provider qualifies as a source. So I'm going to say implements source, like so. And you'll notice that I get no error messages. If I were to change anything inside of here, so if I, let's say, remove this return type, or how about, I'll tell you what, let's just change the name of fetch top IDs right here. It's the instant I change the name of that function, I get the red underline right here that says missing concrete implementation of fetch top IDs. So that is saying, hey, you're trying to implement the abstract class of source. If you want to do so, you have to provide what is referred to as a concrete implementation, or like an actual method that implements the logic that is expected to be contained inside of fetch top IDs. Okay, so I'm going to restore this back to how it was before. Oops. And there we go, error message goes away. So now we'll import this thing into our DB provider as well. So here's my database provider. I will import repository.dart. And then this thing is going to extend, or excuse me, not extend, sorry, spaced out there for a second. It's going to implement source. Now, as soon as we add in implement source, we get the red underline right here, and it's saying, hey, you're not implementing fetch top IDs. So again, remember, this is just a big caveat. Like I had said just a moment ago, our database provider does not actually implement top IDs, but as we said a while ago, yes, it absolutely could. We're just going to kind of pretend for the purposes of this course that the database provider does implement fetch top IDs. And so to kind of pretend that it does, I'm going to define fetch top IDs inside of here, and I'm just going to kind of pretend and say that it returns our expected return type of future list int, like so. And then inside of here we can put any return statement, and we can like return null. So essentially we're saying we're never going to call this function, but maybe we'll put on here like to do store and fetch top IDs. So by just defining the function, even if the function doesn't really do what we expect, that still qualifies as implementing the abstract class right here. So that's kind of where you get into trouble with abstract classes. Yeah, we can say that, sure, I define fetch top IDs, but if your function of top IDs doesn't actually do anything, or if it has the wrong implementation, well, things are not going to magically work themselves out. So all this abstract class stuff only goes so far. Okay, so that looks good. That's pretty much it. Let's take a quick break. We'll come back and we'll take care of our abstract class cache as well. So quick pause, and I'll see you in just a minute. In this section, we're going to implement our abstract class of cache. So the only thing that we really expect a cache to fulfill is the ability to have an add item method. Anytime we call add item, we're probably going to want to be able to pass in an item to be stored. All right. So inside of my cache abstract class right here, I'm going to define a method called add item. And this thing has to accept a single argument that will be an item model, and we'll just refer to that as an item. And then if you go back over, we'll save this file, we'll go back over to the DB provider. So now, in addition to implementing the source abstract class, we're going to say this thing also implements the cache abstract class. Now, if you go down a little bit to where our current add item method is, you'll notice that in reality, anytime we call add item, we're returning the result of db insert right here. And db insert, this is a feature of the SQLite package we're using. It returns a feature that resolves with an int. And so just to be like 100% complete, I am going to go back to the abstract class right here, and I'm going to annotate that as well, like so. Okay, so that is pretty much it. We've now got our two abstract classes. Now the last thing we have to do, and this is where the real pain is going to come in, it won't be that bad. We're now going to start to refactor our class repository right here, and we're going to make sure that it can work with any arbitrary provider, and more importantly, any number of providers as well. Because remember, that was the whole original thought here. We had said that we wanted the ability to add on some like new mystery provider and just have everything kind of work out. So it's not enough that we made the abstract class. I now want to do a refactor of the repository itself and make sure that we can specify any arbitrary number of caches or sources that are going to work inside of our repository. So quick break, and I'll see you in a minute. In this section, we're going to start to refactor our repository class. So I want the repository to work with any arbitrary number of sources or caches that we load up. Right now, we've got this kind of very specific slot for a DB provider and a very specific slot for an API provider as well. And so I don't want to have these specific slots that interact in this very prescribed fashion. I want to instead have a list of different sources and a list of different caches. and then we're going to start to refactor fetch top IDs and fetch item to work with those lists instead. So let's get started with this refactor. I'm going to first take the two instance variables we declared right here, and I'm going to delete them both. And then we're going to make an instance variable of type list that is going to contain a bunch of source objects, and I'll call this sources. This is going to be a list of sources, and then inside of here, I'm going to write out all, excuse me, not sources, just source singular. And then inside of this list, I'm going to write out all the different classes that I want my repository to respect or treat as a source of information inside my application. So the two sources that we currently have access to are the news DB provider and the news API provider, like so. So as soon as I put that code in, notice how we're not getting any error messages here. The Dart compiler is saying, okay, I understand you're trying to make a list of type source. It's going to look at this value right here. It's going to see that our NewsDB provider implements the source interface, and the News API provider also implements the source interface as well. So these both qualify as being sources. Then underneath that, we'll make a list of all of our different caches. So make a second list that I'll call caches. This will hold elements of type cache. And inside there, I'm going to make a single instance of NewsDB provider, because that's the only class inside of my application that implements the cache interface. Okay, so hopefully now it makes more sense when I say I want to allow my repository to work with any number of sources. So we're now going to start to refactor fetch item right here. Anytime someone calls fetch item with a given item ID, we're going to iterate down the list of sources. And we're going to look at each source in turn and say, hey, do you have this given ID? If you don't, we'll move on to the next one. Do you have this given ID? And then if you don't, we could possibly move down to the next one. So now you can probably start to realize how we could very, very easily add in additional providers into our application. So if we now had like news mystery provider, all we would have to do is add that into this list right here. And then pretty soon our fetch item method will start to look at the NewsDB provider, try to find a given item. If it's not there, it'll move on to the next one and then move on to the next one. And that's all going to happen automatically. And so this approach is so much more reusable than what we are currently doing with this very kind of one-off, very conformist logic right here. Maybe conformist isn't the right word, but I think you get the idea. Okay, so let's take one more pause. We're going to come back to the next section and we'll start to refactor the fetch item method. Now that we've established our list of caches and our list of sources, we're going to start to refactor the fetch item method inside of our repository to iterate over all these sources and try to find the given ID from each of those in turn. So we're going to inspect each source one at a time, and then if the given source does not have the item ID we're looking for, we'll move on to the next one. So let's get to it. I'm going to first get started by deleting everything inside of my fetch item method. I'm then going to declare a for loop inside of here that's going to iterate through each one of our sources. Now I'm going to write out the for loop just in a kind of an interesting fashion here, and I'll tell you why in just a second. I'm going to first get started by declaring a item model variable. So that's going to be a variable that holds an item model. And I'll also declare a variable that's going to hold a source as well, and I'll call that source. And so this is the part where I said I'm going to write the for loop in an interesting manner, and I'll tell you exactly what's going on. So now the for loop. So we're going to say for each source in the sources list, I want to call source.fetchItem and pass in that item ID. Fetch item is an asynchronous operation, so we're going to await for that source to fetch the item. When the source fetches the item, it's going to return either the item itself or the value null. So if a given source has never seen this item before, fetch item will return null, and so the item variable over here is going to be null. So item is either going to be the value null or the item model we are looking for. So right after doing the search, we'll say if item is not null. So if we have found this thing, then we do not need to continue iterating through any of our other sources. So we can safely break out of our for loop and not continue iterating through. Okay, so just so you know, we did not have to pre-declare our variables right here for the for loop. I pre-declared the variables up above because now we can reference these variables in the scope outside of the for loop. So whenever the for loop right here breaks, the value of item and source will be equal to the item that we just found, and source will be equal to the source that we just found it from. So now at the bottom of our function, we can return the item that we just successfully found. Okay, so that's kind of an initial implementation of fetch item, but one thing I want to remind you about is that if you remember how we had originally wanted this repository to work, we had said that if we find an item that we've never seen before, we're going to go fetch it from the API and then eventually back it up to our news DB provider, which we are now referring to as a cache inside of our application. So after we find the item, we'll then iterate through all of our different caches. So I'll say var cache in caches, and I'm going to call add item on each one of those caches. So I'll say cache.add item, and I'll stick the item inside there, like so. All right, so now we can come back here and we can add in as many sources as we want. We can add in as many caches, and our fetch item function is going to just automatically work the way you expect. It'll look through the list of sources until it finds a match. As soon as it finds a match, it will stop looking through the other sources. It will back up that item into all of our different caches, and then it will return the item that was found. And so I think you can agree with me, this code right here is about 5 million times more reusable than what we had before. So this looks really fantastic, but there's one or two very tiny edge cases here. So let's take a quick pause, come back to the next section, and I just want to fix up one or two loose ends. So I'll see you in just a minute. In the last section, we fixed up a little bit of a gotcha around our NewsDB provider, because remember, SQLite does not really like it when we try to open up multiple connections to the same exact database, which would have happened if we tried to create multiple instances of NewsDB provider. Now, the second little gotcha I want to mention here, remember that with our DB provider, we had been expecting to call this init function before we actually make use of the thing. So right now, we're just creating a new instance of the DB provider down at the very bottom of the file, and we never actually call init on it. Now, unfortunately, we cannot call init down here, but just as a very easy workaround, we can just define our constructor method inside the NewsDB provider and call the init method from there. So inside of NewsDB provider, I will define my constructor, and inside there, I'll call init. And that's it. That's all we have to do. Okay, that's it. That's gotcha number 2. Now there's one last gotcha. It's still related to the cache of NewsDB provider. We'll take care of that last one in the next section. In the last 2 sections, we fixed 2 little gotchas around our NewsDB provider. So we're now successfully creating just one instance of the DB provider, and we're making sure that we call init on it before we make use of it inside of our repository. Now, last thing we have to do inside of our repository is make sure that we fix up fetch top IDs right here. So fetch top IDs, if we were putting together a full featured implementation, we would iterate over a list of all of our different sources. But remember, we put together a fake implementation of fetch top IDs inside of our DB provider. And so we just put this thing inside of here just to satisfy the interface or satisfy the abstract class. We don't actually want to call this thing. So back inside of the repository, for fetch top IDs, we're going to kind of just cheap out on this function right here, and we're just going to directly call the API provider's fetch top IDs function. So rather than looking at API provider right here, I'm going to look at my list of sources. I'm going to look at the source at index 1, so that would be the news API provider right here, and I'm going to call fetch top IDs on it. So again, kind of cheaping out here, I would probably put a to-do right here that says iterate over sources when DB provider gets fetch top IDs implemented. So for actually implementing fetch top IDs, it would be pretty darn straightforward. We would write a for loop very similar to the one right here, where we iterate over all of our different sources, call fetch top IDs, and as soon as one source returns a list of IDs, we would then break out the for loop and return that from the overall function. But again, we're just kind of taking the shortcut just to save time in the course, because things already are getting a little bit long. Okay, so that's it. I think that we're all done with our repository. Now, just so you know, there's like 1 or 2 very, very small bugs still left inside the repository and the associated providers that we're going to come back to over time as we start to actually build the application out and see those error messages. But these are errors that I want you specifically to see rather than me just fix them and say, oh, look, like, here you go, it's working. So not 100% done with the repository, but definitely close enough. So I think this is a good time to take a pause. We'll come back to the next section, and I think it's finally time to work on the actual application, which I'm sure you're excited about. So quick pause, and I'll see you in just a minute.